Today's video features an item taken from the British Mathematical Olympiad 1996. A function f is defined over the set of all positive integers and satisfies the following conditions. F of 1 is equal to 1996, and the sum f of 1 plus f of 2 up to f of n is equal to n squared times f of n for all n greater than 1. Calculate the exact value of f of 1996. One way that we can approach this problem is to derive a recursive formula that is equivalent to the given formula, and then use this recursive formula to determine some function values and some patterns that we can use to solve for f of 1996. To do this, notice that the terms prior to f of n are f of 1, f of 2, up to f of n minus 1. Alright, so this is n squared times f of n. Now, by definition, the sum starting from f of 1 up to f of n minus 1 can be written as n minus 1 squared times f of n minus 1. So the given equation or formula is equivalent to n minus 1 squared times f of n minus 1 plus f of n equals n squared times f of n. Now let's solve for f of n. We can gather the terms with f of n. So we have n squared times f of n minus f of n equals n minus 1 squared times f of n minus 1. Now, we can factor out f of n in the left-hand side to get n squared minus 1 times f of n. Now, let's divide both sides by n squared minus 1. So n squared minus 1, n squared minus 1. So we cancel n squared minus 1 and get f of n equals. Now, I will write n minus 1 squared into n minus 1 times n minus 1. Also, I'm going to write n squared minus 1 into n plus 1 times n minus 1. So this fraction is multiplied to f of n minus 1. Now we can cancel n minus 1, and then we come up with the equivalent recursive formula f of n equals n minus 1 over n plus 1 times f of n minus 1. Alright, so if you notice, this recursive formula is much simpler than the given formula. Now let's plug in n equals 1996 or 1996. So f of 1996 is just equal to 1996 minus 1, so that's 1995 over 1996 plus 1, so that's 1997 times f of 1995. Alright, now let's solve for f of 1995 using the same formula. If we do that, we will get f of 1995 equals 1994 over 1996 times f of 1994. Alright, now we can replace this one by its equivalent. So this one becomes f of 1996 equals 1995 over 1997 times 1994 over 1996 times f of 1994. Okay, so let's repeat the process one more time just to determine a clear pattern in the right hand side. Using the same formula, we will solve for f of 1994. So that is just 1993 over 1995. Notice that the denominator is always 2 more than the numerator. Okay, so this fraction multiplied to f of 1993. Okay, now we can replace this one by its equivalent. So we have f of 1996 is equal to 1995 over 1997 times 1994 over 1996 times 1993 over 1995 times f of 1993. Alright, so now it's very clear, right? The pattern is very clear. If we continue the process, we should get what? We should get f of 1996 equals the following times 1994 over 1996 1993 over 1995 all the way to 2 over 4 times 1 over 3 times f of 1. Okay, now what do you notice? We can actually cancel out some common factors. In particular, we can cancel the numbers from 1995 all the way down to 3. Right? So we are left with f of 1996 equals 2 over 1997 times 1996 times f of 1. But what is f of 1? F of 1, take note, is just equal to 1996. So we can replace f of 1 by this number. So this is equal to 2 over 1997 times 1996 times 1996. So we can cancel out 1996. So we're left with the final answer, f of 1996 is equal to 2 over 1997.